Yeah, so before we actually start, I'm the MC for the rest of the day. I told Pi that I'm all hers today. So just wanted to mention this one major thing that has happened today, which is to all the ladies in the house, Happy Women's Day. So a shout out to all you ladies. Yeah, I understand we just had lunch, but we can give a huge round of applause to all the ladies once again. Thank you, thank you, thank you. Okay, so this talk is really, for all the people. You've already seen the topic of the talk. So I'll just introduce the amazing speaker who's going to come on stage. The name of the speaker is right here, but I'm going to still say it. It's Alan Schlesser, and he's the principal architect in Yoast. Obviously, he's the person who's responsible for navigating the complexities out there. So you can obviously understand that he's going to be making things a little simple out here, and that's what it is. Along with that, the reason why I know Alan is because he's been a maintainer for WPCLI for a long, long time, and yeah, the hooting should continue. And this is the power that you should show to all the speakers out here. So guys, put your hands together for Alan, who will be doing the talk. Yeah.
Thank you. Hi, everyone. Thank you all for coming to my talk. I'll try to bore you not too much. I'll try my best. The talk I'm giving today is about code quality, so software quality in general. It is not super detailed, so I will not be covering too much code. There's a few code examples, but not too much. So hopefully everyone can make use of the more conceptual nature of the talk. I want to really try to get you to approach your problem solving when you need to create software in a different way. So I have a bit of a mindset shift. Now let me try if this clicker works. Awesome. So let's start with a story first. There was once upon a time a young little machine called the Mars Climate Orbiter. It was built by NASA as part of an ongoing series of missions to explore Mars. It was launched on the 11th of December in 1998, and its goal was basically to enter the orbit around Mars and keep circling around Mars to capture climate data about Mars. And it was part of a larger initiative where that data would be used for later projects as well. When it tried to enter the orbit, the navigational data that they received in the NASA control center was a bit misleading. They had discrepancies in the data, and during the entire trajectory, they were already seeing these discrepancies, but they didn't try to do any changes. So the calculations were that the parallapse at altitude, so the altitude at which it would try to enter this orbit, where it would then automatically circle around the planet, that was calculated to be ideally at 226 kilometers. Then, when it started approaching the planet, gathering more data, all of a sudden the calculations changed. So they had an altitude that was 150 to 170 kilometers. And then, when it really approached the orbit, all of a sudden, with more precise data, this was 1 hour prior to the actual insertion into the orbit, the calculations said that it should be at 110 kilometers of altitude. And at that point, it was known that the survivable altitude was at 80 kilometers. So it couldn't possibly go below 80 kilometers, otherwise it would just crash and burn in the atmosphere. So all of a sudden, these calculations, they came closer and closer to this fatal threshold. And then finally, on September 23 at 9 o'clock, the engine started to launch the insertion process. And at about 4 minutes in, they lost signal to the Mars climate orbiter. They assumed that they would lose the signal when it goes on the backside of Mars. But the signal loss came 49 seconds too early, which was really unexpected. And since then, they have never been able to reestablish contact anymore. And so, after the fact, they try to find out what what had happened. And as it turns out, it was entering the orbit way too low, so it was directly flying into the atmosphere of Mars. And when it lost signal, it was not because it was getting behind the planet, it was because it had crashed and burned, because it was way below that, that safe altitude. So the report that came out afterwards to find out what actually happened generally said that because of software error, the spacecraft encountered Mars at a lower than anticipated altitude and disintegrated due to atmospheric stresses. So that was the official outcome of this. And what it actually meant was that the software that was supplied by Lockheed Martin, one supplier, produced results in one unit, and it was then consumed in another unit, assuming another unit, to make decisions. And so there was always a discrepancy between the signal getting recorded and the signal being interpreted, because two companies made assumptions that produced a mismatch. So everything was converted at a factor of 4.45 or so of error conversion, and the result was a loss of $327.6 million US dollars, because two companies couldn't agree on the unit to use, and they just assumed on both sides that the unit they were using was the one that was in use anyway. And so this assumption was a very costly one, and that was the root cause of why this entire mission ultimately failed. Then we have a similar example, albeit a very simple one. We have this piece of PHP code. So at first not very relatable to a Mars mission. But what they have in common, so this is really silly code. This is not something that you can now copy paste and use somewhere. This doesn't make any sense at all, but it's just meant to serve to illustrate a point. What they have in common is that there's all sorts of assumptions that are made that are left unchecked. With this code, I just want to show you how easy it is to miss some of these assumptions. So that's why the code is so simple. We have a function that is meant to fuse two values. It has a total and increment, and then it fuses those with a magical operation. Assume this is a black box, and then it returns the total. So we have assumptions and we have assertions. And here, the assumptions, they might not immediately be obvious. So we call the operation fuse, and we accept two arguments. And now someone who wants to consume our newly created package, okay, they now use this function. So they want to fuse Goku and Vegeta. And they want to create a new fusion. For those that are a bit more into anime, they probably get the reference here. They want to create a fusion, but of course the end result will not be what they expect. Do you know what the actual result is of running the code with the purple background here? Who can confidently say that they know in PHP, so this is PHP code, what will be the end result of this operation? What do you think? Yes, that's a valid assumption, but it's wrong. The thing is, with everything, with operations that are not clearly defined, it's very easy to make assumptions, and very easy. Thank you for the example. And this is of course not to bash you. It was meant to be very misleading for obvious reasons. So in PHP up to version 7, this will return the integer value 0. In PHP version 7.1 to 7.4, this will return the integer value 0 with a warning that a non-numeric value was encountered. And in PHP 8 onwards, it will create a hard fatal error, a type error, saying that unsupported operand types string plus string were encountered. So not only will it produce the integer value null when it actually produces results, but it also produces inconsistent results. So this is really the type of bugs you really don't want in your code, where not only does it break, it also breaks contextually, depending on where you run it. So the thing is, these assumptions are, one of them are the type. We didn't actually enforce any typing here. We made the assumption that while we create a fuse function, everybody knows how to use a fuse function, right? And the arguments are even labeled, so what can possibly go wrong? But the thing is, if we not enforce a given type, somebody will misuse it. And you will have to deal with the results of that. But if we now try to add an insertion here, we have the integer version of these arguments, so we can see we're strongly typing this against integer. The two arguments are integer and can only return an integer. So this assumption is then properly cleared. Now nobody can try to use this function with two strings, and if they do so, they will actually have an error on their own end saying that they are just using it wrong. So your own code will not be the part that is breaking, their code will break. So you have already one piece of your code that is free of this assumption. Because ultimately every single assumption that is left unchecked is a potential bug. It is not a guaranteed bug. Sometimes it's still correct if you assume something. But it is a potential bug as long as you're not verifying that it is actually correct. And what's more is that this is not the only assumption that is in that code. So we fixed these with integer type-ins, and this operation here leads to another problem, another assumption. And that might be less obvious, because here we're incrementing integer values. And the assumption is that we can do this an infinite amount of times with infinitely large values, but that's not actually the case. What we need is to check to make sure that we're not overflowing the maximum capacity of what an integer value can actually consume. So every data type has limitations. That is generally the case when you're adding something. You need to make sure that you're also observing the limits to this addition. We just assumed that we can do this without watching for anything else. So here we have another check where we're first making sure that this maximum is not overflown. However, there's another assumption. Can anyone spot another assumption that is in that code? And it is maybe less obvious. Yes? Exactly. There's someone paying attention here. The increment can be negative, so assuming that the increment is only positive is another assumption that it was never enforced, so that is not an assumption you can make. If the increment is possible to be negative, you need to deal with the possibility of that. You cannot just assume that everybody will just follow the happy path of your code. It can be negative, so you need to deal with the negative case. So now, as we have dealt with these assumptions, we have one piece of our code where we can sleep easier at night, because we know that when there's a problem, it's probably not in that part of the code. We really have hardened it. So all of these things are basically the same mechanism. We made an assumption and we didn't double check that the assumption is true, and in case it is wrong, it is a bug. So what happens if we now just try to generalize this, into a strategic approach we can take when doing software construction, where we just say, I want to be as systematic as possible in reducing these assumptions, because every assumption I make is a potential bug. So the less assumptions I make, statistically speaking, I will have less bugs. That is just, statistically speaking, is something that will be the end result. Every single instance of that doesn't say much, but statistically, the end result will be less bugs. So that's what we want to look into. Every single assertion that we make is not a potential bug, but it basically says that in this part, for this reason, there's guaranteed to be no bug. And then what we also add here is if we make assumptions, those assumptions, they multiply across your code base. And all of a sudden, there's no part of your code that is safe anymore because you introduced some ambiguity somewhere and it grows into this huge mega bug that is really hard to track because your internal consistency is just not given. And instead, when you create these assertions, I noticed the font is wrong, sorry about that. If you create these assertions, this also documents everything you have already checked. So on one hand, this helps with skill transfer and with checking that all the right assertions are in place, that no assumptions are left unchecked. And also when you actually need to hunt down for another bug, when you might have missed an assumption, it's much easier to go through because you already see what was considered. So, assumptions are potential or latent bugs. We want to get rid of them, and checks and assertions are guarantees. So we want to have less potential bugs and more guarantees, and the end result will be hopefully less actual bugs. So that's the talk. But now, yeah, okay, how? This is easier said than done. So let's try to go through a thought experiment first, and then I'll show you a few examples. So first of all, the general approach is you have a problem, you let it go through a process for software design, discovery, planning, whatever, and you end up with a solution that you build. You want to make sure that your solution is correct. The thing is, first of all, how can you check whether the solution is correct? One thing is that you can have all sorts of automated testing and so on in place, but usually that type of testing that checks whether the solution matches the expectations. So, one issue is that the expectations are what we produced during the process. However, given the same problem, if we have a different process, we end up with a different solution. So, do we know whether our process is actually correct? Sorry for this is a bit confusing. Sorry for the latency here. Do we actually know that our process is correct? With the problem, there's also the fact that if we have a different problem that we're trying to solve and we apply the same process to it, we also end up with a different solution. So we also need to know whether our problem was correctly identified. And that means that if we want to really do this systematically and get rid of assumptions, it needs to start at the problem space, not the solution space. We first need to make sure that we don't make assumptions about what problem to solve. Because otherwise, no matter how strong our typing is, if we solve the correct problem, it's wrong, it's just bad. And we're not talking about single software bugs here, we're talking about software failure. We're talking about projects that fail as just a larger version of a bug in our thinking, a bug in our execution. And so we want to really go the entire way and do this for the entire process. So what I thought about is that first you should think about what the dimensions are that you're working in. When you look at the traditional definition of software quality, you have process quality, you have the structural quality, and you have the functional quality. So how are we solving problems? Are we solving the problems correctly, and are we solving the right problems? These three dimensions are generally what you consider when you're talking about software quality. When you do automated testing, for example, that would be the structural quality. Are we solving problems correctly? But if you then do user acceptance testing, that is the functional quality. Are we actually solving the right problems? And all of that is tied in a process that makes sure that we correctly collecting data, we're feeding the data back into the development process, and so on and so forth. But this traditional display of software quality doesn't look at this iterative approach of slowly converging towards a system where you introduce less assumptions. So what I propose is that you think about software quality in a revised way. First of all, by having functional and structural quality, they need overlap. They need to have a way of checking each other to making sure that you cannot have perfectly fine unit testing that perfectly solves the wrong problem. You don't want to have one thing be completely independent of the other. They need to counter-check each other to make sure that you cannot fool yourself into the wrong confidence by having tests validate something where the test just start with the wrong expectations. So that's why there needs to be overlap. And then the process quality should be something that envelops the entire thing. Where imagine that you're doing this automated testing, and then there's requirements change, and you make changes to your code, and then you run the automated testing again. Everything is green. Okay, we're good to go. But how do you know then that your tests are actually testing the changes in the requirements needed? Because it might just as well be that your tests don't actually cover that part of the code, or that they don't cover that approach to solving the problem. So the entire process needs to be built in such a way that there's always like this double checking for everything, where like for example, you might get the requirements in such a way that as soon as these requirements are part of your project, your tests start to fail, no matter what. And you need to make changes to get the tests into a green state again. So this all should be something where everything relies on each other to make sure that you cannot get to a sense of false confidence where, again, you have assumptions that are unchecked. And so there's 3 phases, I think, that you should go through when you want to manage that. First of all, there's the clarify phase, and I completely came up with these phases. So this is not something you will find in books. That's just my way of thinking through it. First, you need to have a clarify step. You have requirements, and that is what the client wants. They told you, yeah, we need X, Y, Z. And probably everyone who has worked with clients has already had the situation where the client is very adamant that this is what we want now. We need to build this. However, the thing is that there's also the problem domain, and there's the boundaries of an acceptable solution that also need to go into the requirements. So when you collect these requirements, don't only listen what the client wants, because you also need to know what the client actually needs, which is not necessarily the same thing, and you need to know what the client can actually use, which is also, again, a different thing. And your requirements should include all of that and come up with a solution that solves for the entirety of that. Because otherwise, you might actually build the thing that the client wants, and the client cannot use it, and it's not what it needed, what they needed. So that is, when you try to clarify the requirements, make sure that you clarify all requirements. And there's functional requirements, so the features of the software. It needs to be able to print in color. But then there's also the non-functional requirements. Those are the properties of your solution. It might be that there's really hard restrictions, hard thresholds that you need to hit in terms of performance, for example. You're building an API for someone, right? Every time you do a request, it just takes 3 hours to solve. Okay, it's completely unusable. If the performance is a factor in the success of the project, it needs to be a part of the requirements, and you need to solve for it. This is the same for performance, security, reliability, usability, all of these non-functional requirements. If there is a hard limit, a hard requirement for any of these, they need to be part of the planning. And then there's also the boundary conditions. There might be laws in place. So yeah, if the client needs insights into their customers, it's great to collect all the data that you can get from your customers, but there might actually laws that tell you that you're not allowed to do that. So all of those are also requirements that need to go into this process. And then documentation is key. any requirement that is not documented, it cannot be validated. Nobody can actually check whether you made the right assumption there. It cannot be verified and it cannot be relied upon. So you need to document everything so that it can also be challenged. Because it's fine if you identify a requirement, but if you then build the code and build the solution and publish it, nobody was able to actually challenge whatever assumptions you made there. And you don't want to make assumptions. So every time you might be making an assumption, it helps to have other people double check what you're deciding, what you're assuming. So if it's not challengeable, you cannot use it. So document everything. Then the second step is the verify step. And what I'm thinking about here is that after you clarified what you need, you came up with a set of expectations. And then the verify step is that you need to make sure that those expectations make sense before you start building something. That's the verify step. So again, documentation is key because behavior that is not documented, it cannot be trusted and it cannot be relied upon again. So, for example, if you build an interface for something that someone else is supposed to rely upon, then of course that needs to be documented, and ideally you'll document it and you test that the documentation, the specification and the actual behavior are all in sync. This is very important. Then you should have contracts in place. Here I try to visualize a bit how you can think about this. Imagine that you have the internal behavior and you have your package under development. And usually you might have dependencies that you pull in. It's rare that for a non-trivial piece of software that you build everything from scratch. So you'll have dependencies. So part of your internal behavior will connect to the dependency through an interface and rely on that. And then you have on the other side, you have a consumer where you provide an interface and they consume your behavior. So your package does things and then has an interface so that people can make use of the results. The thing is that you need to verify the documented behavior you rely on this end, and you need to verify and document the behavior others should rely on this end. And those are the boundaries of your system. The internal behavior is not that important, but those boundaries, that is where there can actually be bugs where it's not that your code is incorrect or someone else's code is incorrect. It's just like with the Mars climate orbiter, you were not in sync. You had a mismatch in your assumptions. So that is very important that you make it as hard as possible to have these mismatches in place. Again, a silly code example. So which ones of these are correct? Can you see it at first glance? It's probably hard to see from there. Because all of these look like they might potentially be correct. However, if you're not very, very used to the weird behavior of PHP and you don't double check in documentation, chances are pretty high that you get it wrong. So here in this case, it's a rather weird mixture, which ones are correct and which ones are not correct. And that means always read the fine manual, please. It's very important. Then the third step is assert. And so now we build up our expectations. We verified that we came up with the right expectations and that everyone else has the right expectations on us. Now we need to actually enforce things. So we want to first, if we have a large system, we want to create and enforce boundaries. The thing is that if we have a large enough code base, it probably operates in multiple layers and multiple levels of complexity. And we do have an expected behavior, but it's also for every single place where nothing is enforced, we will have more and more ambiguity and uncertainty that gets included into the code. So this is something where as the code execution goes from layer to layer, the uncertainty is actually growing, and the possibility, the potential for bugs is actually growing. And what we need to do is to actually build in boundaries where we have hard checks on just letting only certain types of code and data through, making hard failures when expectations are not met, making sure that the interface is correctly respected, and so on and so forth. So these boundaries where from time to time we just do a reset while going from one part of the code to the other part, makes sure that we have the growth of this uncertainty under control over time. It cannot grow uncontrollably. This can be done, for example, by retyping at boundaries. So if you look at how WordPress behaves, you have your code that uses a filter. So apply filters goes to WordPress. Then WordPress will then execute plugins. The first plugin gets the filter function, does something with it, returns it. The next plugin gets the filter function, does something with it, return it. So this value is being passed around and is potentially being manipulated. And at the end, you get it back at some point, but do you really know what happened to it? You cannot possibly know what happened to it. So in that case, it is important to actually assume that it was manipulated, assume that it might potentially be wrong, that it might not be the right type or the right structure anymore. So even though you started out with the correct type, after passing something through a filter, reinforce the type. We're doing this here with a class that has its own validate function. So not only are we enforcing the type, but we are also enforcing the internal structure of the data. And even though we started with that customer ID type, we're retyping it to make sure that we're still correct. So the worst case scenario is that somebody else made it wrong and it will fail here at this point. So everything after this point cannot fail anymore for anyone having used the filters wrong. That's the type of boundaries we can use. Then there's other types of boundaries. For example, when you're dealing with errors, here we have again this illustration of how a package would be structured potentially. And imagine that you're throwing an exception if you're in an unacceptable case. So you're throwing an exception that is generally part of the interface, and the consumer will then manage this exception and deal with it. The problem though is that what often happens is that the dependencies can also throw exceptions. So all of a sudden, the consumer gets something that is not part of the interface. It's not part of the contract that the consumer has signed with you. So you said, I'm only doing this, but you're actually doing something else. It might be a dependency that is doing that, but the consumer cannot possibly know. They only enter the contract with you. So what you need to actually consider here is that the exceptions, they should be caught and rethrown under your umbrella, under your responsibility, so that they all pass to the same interface, that you are actually documenting that those are also exceptions that can be thrown, or that you're rethrowing them as your own exceptions. And this means that the responsibility according to the contract you're entering with your consumer, it includes the dependencies you're adding. You cannot just say, well, those are the dependencies, that's not my fault. Because the consumer, they assume that you're only doing the things that you have in your interface. So you can rethrow at boundaries by basically trying to think about everything that can go wrong, possibly go wrong, and then make sure that there's nothing that can get past that barrier. So at that point, you're sure again that you have full control over what happens next. So to summarize, assumptions can hide everywhere. They can hide throughout the entire process. It's not just at the precise code level, but also at the design level, at the process level. All of those need to be checked. They can be in all parts and all layers of your system. And every assumption is a potential bug. So the less assumptions you have, the better you're off. So eliminate assumptions that will statistically reduce the number of possible bugs. Of actual bugs, statistically speaking. And So the steps that I recommend you think about when you're going through this process, first, clarify to make sure that you properly understood the problem is documented, and you know exactly what the expectations are supposed to be. Then verify that you actually came up with the right expectations, and then assert that everything is according to these expectations and that cannot possibly be anything else. That is basically the systematic way of getting rid of more and more assumptions. You will not be able to do this perfectly, of course, but again, statistically speaking, this will be a definite improvement of your code and of the quality of the software you're producing. Thank you very much. Mr. MC, please.
I got too mesmerized by the talk, you know. And then he was returning the favor of calling me to the stage. But yeah, huge round of applause once more, guys.
Thank you.
And as a token of appreciation, I would like to, give a token of appreciation to you. So here we go.
Thank you.
Thank you so much, Alan. Just a quick question as to when did you step into the world of technology? Not specifically coding, but the world of technology.
That has been a very long time ago.
And that's the reason why I asked you.
That was at a very young age. I was just fascinated by computers when I got the first access to the first one, and I think it was 7 or so. That's when I started programming in BASIC, if anyone remembers that time, maybe.
Okay, so what was the time like? I mean, how did you...
That was 1987, and that was on a Commodore C64, so that had a lot of other assumptions that were included in the system. It had very different requirements to today's machines, but yeah, that was my entry point.
So ladies and gentlemen, before I was even born, he started coding, so thank you so much. Thanks, Alan. Thank you so much.
Are there maybe other questions?
Oh, yeah, please. If you have any other questions, I've done my questions. I would like you guys to ask your questions.
He's covered.
Yeah, I'm good.
Okay, great. So my question is, as the person who write the requirement for our clients, how can we make sure that every single aspect for that we are developing can be able to serve to our customer? Because there is some situation that happened recently that we designed the system and then our client said that, hey, this is not the thing that we want. We need something more than that, and they didn't specify anything from that. And how can we try to convince them to tell us more detail about that?
Yeah, thank you for the question. That's a really great question. So, first of all, you should really make sure that you understand what problem the client is trying to solve. So usually the client tells you about the solution they would like to see, but you really then need to drill down. There's systems like the 5 whys or so where you're constantly asking them, yeah, okay, you need a green button. Okay, why do you need a green button? Well, I need a green button so that somebody can push on it so that this happens. Okay, why does that need to happen? So you need to drill down to get to the bottom of what the actual problem is they need solving. And oftentimes it already fails at that step because the client doesn't know what the solution is supposed to be. So if they tell you, assume that they're wrong. They are not the expert in solving those problems. They should let you know what the problem is. But it's really difficult for clients to actually understand it and express it correctly. That's why it's your duty to then drill down deeper and deeper and deeper until you get to the bottom of it and really understand in detail what the actual problem is. Usually you need to get to a point where you're trying to solve a business problem. Clients start with, yeah, technically it needs to do this and that. But you need to drill down to understand what is the business problem you need solving. And as an example, you might have a butcher that comes to you that says, my website doesn't have enough visitors, there's not enough traffic, I need better SEO. Okay, then you need to do more SEO, they get more traffic, they get more online orders or whatnot, but they cannot fulfill them because that was never a business problem they had in the first place. So just doing what the client wants is not the right approach. You really need to drill down to understand the business problem that needs solving, the actual pain points. Then once you have that, as I showed these lists before with the functional requirements and the non-functional requirements, you should really have for you internally a checklist to go through to make sure that you covered all the aspects, that you asked questions about each of these aspects to uncover requirements that were not obvious at first, but that actually happen to be important for your client. And then finally, you need to document everything so that on one hand, you have a document that allows the client to clearly verify the results, the conclusions that you came to, so that they can really challenge that they can see, okay, that's the conclusion, yeah, that makes sense, seems like you're heading in the right direction. But also as a tool for yourself to actually let the client sign off, and then in the worst case scenario, because it might be that they ask you for a solution to a problem now, then you build it, in 6 months' time you deploy it, and then their problem has changed. So you really need to make sure that on one hand you're documenting what the client has agreed to, if it's in enough detail, so that that can protect you, but also then include a process where, like an agile process also, where you work iteratively and constantly revalidate whether you're still solving the right problem. And so, yeah, going in more detail will now be way out of scope, but that should be the general approach where you really need to do your due diligence to make sure that you get the best possible start into the project, and then give the client enough input points where they can help you adapt it if needed, and then finally make sure that you're protected in case the client just changes his mind on a whim and it's not what you agreed on.
Thank you for the question. Do we have time for another question? Okay, so Alan will be around, I'm sure.
Yes.
And you can ask your questions, just find Alan and, we'll be able to answer any questions that you have.
Find me.
Yeah, so easy to find. I mean, this guy's never, mistakable. So, all right, guys, thank you so much, Alan. Thank you so much for your time. It was a pleasure. Thank you.
Thank you.